Have you ever stopped to think about what's really going on inside your favorite gadgets? We're about to peel back the cover and find an unsung hero of electronics, a tiny, tiny component that without it, our digital world, well, it just wouldn't exist.
So let me ask you a question. What is the one tiny thing that acts like a microscopic one-way street for electricity, powering everything from your phone and your car to the very internet you're using right now?
You guessed it, it's the diode. The best way to think of it is as the ultimate gatekeeper for electricity. It has one incredibly simple but profound job. Let the current flow one way and one way only. And that simple rule right there is the foundation of pretty much all modern electronics.
To really get how this little gatekeeper works its magic, we have to look inside, right down to its core structure. It's something called the PN junction, and trust me, this is where it all happens. So at its heart, a diode is basically an electrical one-way valve. It's brilliant. If you ever look at one up close, you'll see a little stripe or a band on one end. That little marker, that shows you the negative side, the cathode, which tells you which way the current is allowed to flow out. Super simple, but absolute genius.
So how do you build this valve? Well, you start by fusing two special types of material, usually silicon. On one side, you've got what's called P-type material. Just imagine it has a bunch of empty parking spaces, which we call holes. On the other side, you have N-type material, which is like a parking lot just packed with extra cars, and those cars are our good old electrons.
Okay, now here's where it gets really interesting. The second these two materials meet, what do you think happens? Right away, some of those cars, the electrons from the N side, jump right across the junction to fill the empty parking spaces on the P side. This creates this neutral, empty zone right in the middle, called the depletion region. It acts like a natural barrier that stops any more traffic from crossing.
So, you're probably thinking, if there's a natural barrier, how do we get any electricity to flow at all? Well, that's where we come in. We have to apply a voltage in a very specific way, and that process is called biasing. This is basically how we tell our little gatekeeper when to open up and when to stay firmly shut.
So first, how do we open the gate? Easy. We apply what's called a forward bias. We connect the positive end of our power source to the P side, the side with the holes, and the negative end to the N side, with the electrons. This basically gives them a big push, forcing the electrons and holes toward each other and shrinking that barrier. Once we give it just enough of a push, about 0.7 volts for a normal silicon diode, that barrier is gone. The gate swings wide open and the current flows right through.
But what happens if we hook it up backwards? Well, that's called reverse bias. We connect the positive source to the N side and the negative to the P side. And what does that do? It actually pulls the electrons and holes away from the junction, making that barrier in the middle even wider and stronger. The gate slams shut and nope, no current is getting through. That right there is the one-way street in action.
Now, that basic on-off one-way switch is incredibly useful, a total game changer. But you know engineers, they couldn't just leave it at that. They've created a whole family of specialist diodes, each one perfectly tweaked to do a very specific job. You've got rectifiers that convert power, Zeners that act like bodyguards, the famous LEDs that make light, Schottkys that are all about speed, and even photodiodes that turn light back into electricity. And trust me, each one of these is a specialist, a master of its craft. Let's start with the one you see literally every single day, the LED or light-emitting diode. It's a special type of diode where as those electrons cross that junction, instead of just creating a little heat, they release that energy directly as visible light. Every single pixel on your screen, the lights in your house, the flashlight on your phone, yep, they're all thanks to this brilliant little component. Okay, now for a really clever one. Remember how we said that if you put too much voltage on a normal diode backwards, you can break it? Well, the Zener diode is designed to not only survive that, but to actually use it. It's built to operate safely in reverse, acting as a kind of safety valve to regulate voltage and protect the more sensitive parts of a circuit from any sudden power surges. It's pretty amazing.
And then you have the sprinter of the family, the Schottky diode. This thing switches on and off incredibly fast, and it only needs a tiny voltage to open its gate. We're talking around 0.2 volts. That combination of raw speed and super low power use makes it absolutely essential for high-frequency stuff, like inside your computer's power supply.
All right, so we've covered the theory, but now let's bring it all back to the real world and look at the absolutely massive impact these tiny components have on, well, just about everything. I mean, you can see just how fundamental they are. Their number one job, power conversion.
That's happening right now in your phone charger, turning the AC power from your wall into the DC power your battery needs. But they're also protecting circuits, lighting up our world, helping our radios work, and even harvesting energy from the sun and solar panels. They're everywhere.
And when you talk about efficiency, the impact is just wow. An LED bulb, which is really just a fancy diode, can be up to 85% more energy efficient than one of those old-school incandescent bulbs. That is a massive amount of energy saved, all thanks to a smarter design.
And this right here, this shows you why they're so efficient. See that voltage drop? That's basically wasted energy, burned off as heat just to get the diode to turn on. A standard diode wastes about 0.7 volts, but that super fast Schottky diode, it only needs about 0.2 volts. In high-speed computing, that tiny difference adds up to huge energy savings.
So when you boil it all down, why did the diode take over the world? Well, it comes down to a few key things. They're solid state, meaning no moving parts to break, which makes them incredibly reliable and long-lasting. They switch in nanoseconds, a speed that is absolutely essential for modern computing, and they are tiny and cheap, which is how we can pack billions of them onto a single computer chip.
So, if you remember just one thing from all of this, let it be this. A diode is simply an electrical check valve. It's a beautiful, simple function. But the incredible control it gives us over the flow of electrons is what makes all of our complex, amazing technology possible.
This tiny, simple one-way valve, invented decades ago, literally built our digital world from the ground up. It really makes you wonder, right? What's the next seemingly simple component out there that's going to unlock our future?